So very first topic we are having, what is work? In order to understand about the chapter energy, first of all we should know the definition of work. So what do you mean by work? Work is said to be done when on applying force to any object and that object start moving in a direction of force. In that case we will say that work is done. Okay, so what do you mean by work? Work means when we applying force on any object and that object start moving in a particular direction, that is known as work is done. So next we are having some examples related to work. So first example we are having, this man tries to push a hard wall. Means he want to move this hard wall somewhere, but this hard wall is not moving anywhere. Is he doing any work? So as I already told, in which case work is done? Work is done when we are applying force and the object is moving in that action of force. In that case work is done. But obviously he is applying force. He is applying his full effort in order to move the wall, but this wall is not moving anywhere. Here displacement or distance is not there or not shown by the wall. So in that case we will say that work is not done, because in order to do the work both force must be applied and distance should be there in that object in which we are applying the force. So here in this case work is not done. Okay, so next we are having, a boy is reading a book. This boy is reading a book. Is he doing any work? As I already told that in order to do a work, force must be there and distance or displacement shown by that object must be there. So this object is applying some force, okay, but he is not moving anywhere. Here displacement is not there, so this boy is not doing any kind of work. Okay, here work done is 0 or not there. Next we are having, a man walking on a ground. When a man is walking on a ground, is he doing any work? Yes, obviously he is applying force also, force on the ground, plus he is moving or he is showing some distance or displacement also, so he is doing the work. Next we are having next example related to work. A girl is riding a bicycle. So when a girl is riding a bicycle, she is applying her force on the pedals, plus bicycle is also moving. So bicycle is moving, force is also there, displacement or distance is also there, means girl is applying a force or girl is doing some work done. Next we are having, a boy is lifting a heavy load. When a boy is lifting a heavy load, this boy is applying force. Which force? Muscular force. And the object is also displacing. This weight is also displacing or moving from one position to another. So he is applying the work. So yes, work done is there. Next example related to work we are having, a boy is standing at a place with a heavy load on his head. A boy is standing and he is taking a heavy load on his head. Does he doing any work? So see carefully, in order to do work, force must be applied and displacement or distance should be there. He is applying force, fine. But the load is not moving anywhere. No? Load is on the one place only. Load is not moving from one place to another. So here displacement is 0. If distance or displacement is 0, then work done is also 0. So he is not doing any work. Next we are having conditions for doing work. As I already told, in order to do the work, two conditions must be fulfilled. First condition is a force must be applied on an object. In order to show the work done, a force must be applied on any object in order to show the work. And second, we are having condition for the work done. That object, if I am applying force on this object, force applied, fine. First condition is fulfilled. Second condition is the object must move some distance in a direction of force. If I am applying force in this direction, so this object is also moving in this direction. So in this case, you can say that yes, work is done. But here you can see that work can be of three types. Work is of three types: positive work done, negative work done, and zero work done. In which case you will say positive work done, in which case you will say negative and zero. See carefully. Positive work done means whenever we are applying force to any object and that object also moving in a direction of force. Means I am applying force in this direction, from this direction, and box is also moving this direction only. In this case you will say positive work done is there. In which case negative work done is there. For example, a boy is moving on a road or boy is moving on a floor. He is moving in this direction. He is moving in this direction, but the force or frictional force is moving in this direction or applying in the opposite direction. Obviously always frictional force is always in the opposite direction in which we are moving. So here you can say work done is negative. And zero work done, as I already told in the previous case, when a boy is standing by taking load on his head. Load on his head means he is applying force in order to lift the load. Okay, but load is not moving anywhere, na? He is standing at one position. So in this case, you can say work done is 0. So work done is of three types: positive work done, negative work done, and zero work done. Next, we are having measurement of work. In order to measure work, we are going to use two things. First, we are using force. Second, we are using the distance or displacement moved by that object. So as you can see, here in both cases A and B, in A and B case, here displacement is more, means this boy is moving or covering more distance as compared to B boy. As distance is more, if distance is more, then work done is also more. Distance is, if more distance someone is moving, in that case work done is also more. Second case we are having for the measurement of work. So work is going to depend upon two factors: force applied and distance moved by that object. Okay, here you can see this is larger or heavier object, this is a light object. Heavier object means this boy has to apply more force. If he is applying more force, in that case work done is also more. So in A and B case, here A boy is applying more force. More force means more is the work done. More force, more is the work done. Fine. So by concluding these all things, we are going to use it like this: amount of work done by a force is equal to product of force and displacement. Here we are having the relation between it: work done is equals to force multiplied displacement in a direction of force. So work done by any object is going to depend upon two factors. First, it is going to depend upon force applied. Whenever we are applying force to any object and that object start moving in the direction of force, in that case you can see work done is there. So here is the relation: W is equals to Fs. This relation we are going to use in order to solve the numericals also. So see it and note it down carefully. So work is a scalar quantity. Actually, work is a scalar quantity means work is going to depend upon only the magnitude but not the direction. Means how much amount of work is done, we are going to just count that. In which direction that work is done, that is not a matter. So that is why work is a scalar quantity which is going to depend upon only magnitude but no direction. Clear? So next topic we are having SI unit of work done. In order to calculate the SI unit of work done, first of all I am going to write the relation between the work done, force and displacement. So here we are having the formula: work done is equals to force multiply distance. So SI unit of work is joule and it is also going to represent by capital J. Okay, so here we are having its relation: 1 joule is equals to 1 Newton multiply 1 meter. So SI unit of work is joule, SI unit of force is Newton, and SI unit of distance or displacement is meter. So here we are going to see the definition of 1 joule. What do you mean by 1 joule? 1 joule means when a force of 1 Newton is applied on this object and this object start moving 1 meter and object moves to 1 meter, in that case you can say that 1 joule of work is done. So what do you mean by 1 joule? 1 joule means when 1 Newton of force is applied to an object and that object displaces through 1 meter, in that case 1 joule of work is done. So here we are having definition for 1 joule. So what do you mean by 1 joule? When a force of 1 Newton displaces a body through 1 meter of distance, in that case you will say that 1 joule of work is done. Next we are having CGS unit of work done. CGS unit of work done is erg. SI unit is what? SI unit is joule and CGS unit of work done is erg. Here is CGS unit. Okay. So as we can see the formula, work done is equals to force multiplied distance. Here we will see the CGS unit. CGS unit of work done is erg. CGS unit of force is dyne and CGS unit of displacement is centimeter. Clear? Here we will define the 1 erg. 1 erg means when 1 dyne of force applied to an object and that object moves through 1 centimeter. In that case you will say that 1 erg of work done is there. See the definition carefully of 1 erg. So here we are having the definition: when a force of 1 dyne applies or displaces an object through 1 centimeter, in that case you will say work done is 1 erg. Clear? Next, we are having relation between joule and erg. This relation between SI and CGS unit of work done you have to remember only, because full-fledged derivation you will do in the higher classes. So here we are having its relation. 1 joule is equals to 10 raised power 7 erg. This relation is very important from exam point of view also. So note it very carefully. Okay. So a bigger unit of work is kilojoule. Actually, joule is the SI unit and erg is the CGS unit. The bigger unit, if we want to see for the work done, that is a kilojoule. Kilojoule is a bigger unit. SI unit is joule. And what is the relation between them? 1 kilojoule is equals to how many joule? 1 kilojoule is equals to 1000 joule. This is the relation between bigger unit and SI unit of work. Next, we are having numerical problem related to work. First, we are having a child applies a force of 5 Newton. A child is applying a force of 5 Newton, means force is given of 5 Newton to a toy cart, and is able to push a toy cart through a distance of 3.6 meter, and that toy cart or that toy is going to move at the distance of 3.6 meter in the direction of force. What is the work done? Work done we have to calculate. As I already told, work done is having the relation W is equals to F multiply S. Fine. So here we are going to put the values of the force as well as the placement. So here we are having the W is equals to F is 5 Newton, multiply distance is 3.6. When we solve 5 multiply 3.6, we will get the answer 18 joule. So here work done by the boy in order to move the car is 18 joule. Next, we are having second numerical related to work. A force of 25 Newton. So here force is given 25 Newton. Displaces an object through 5 meter. So here distance is given or displacement is given 5 meter in its own direction. Calculate the amount of work done. Same we have to calculate the work done. Work done formula we are knowing, W is equals to F multiply S, where F is the force applied and S is a displacement or distance moved. So W we have to calculate, F value we will put, multiply 5, it will give you 125 joule. So work done here in the case is 125 joule. Next, we are having third numerical related to this. Coolie lift a luggage of 20 kg. So here mass of the, for example, here coolie is there. He lift a luggage of 20 kg. Mass of the luggage is given 20 kg from the ground and put on his head. From the ground he took the luggage and he put in his head. 1.7 meter above the ground, and he took the distance, he show the distance 1.7 meter. Fine. Find the work done. W value we have to calculate against the force of gravity of the luggage. Actually he's taking the luggage from downside to the upside, means against the gravity we have to calculate the W. Against the gravity means simply we have to calculate the work done. As we know the formula of work done, W is equals to F multiply S. So here in this case S is given but force is not there. So how you will calculate the force? See carefully. You will calculate the force by using the formula F is equals to mg. Here you have to remember this relation F is equals to mg, and in 9th class you will come to know about the Newton's law of motion. In that case you will clearly understand how this formula came. So in this case just learn it. F is equals to mg. So here we are having the relation F is equals to M is given 20, multiply G value is given 10. So here you will get 200 Newton. So force we have calculated 200 Newton, displacement is already given 1.7. So just put in the formula. W is equals to F. F is what? 200, multiply distance or displacement is 1.7. So when you will multiply 200 multiply 1.7, you will get 340 joule as the work done by this boy in or coolie in order to lift the luggage. Next, we are having next problem related to work. Show by actual calculation in which of the following case more work done is there. Means in both cases we have to calculate the work done, and we will check in which case A or B work done is more. A force of 7 Newton. So in A case, force is given of 7 Newton, displacing a wooden block through 1.5 meter. So here displacement is given by a wooden block, that is 1.5 meter in a direction of force. We have to calculate the work done. We know the formula of work done. Now you will tell me what is the formula. W is equals to, yes, Fs. W is equals to Fs. Now put in the values. W is equals to F multiply 1.5. So W you will get 7 multiply 1.5 as 10.05 joule. So in a first case, work done is 10.5 joule. In a second case, same, we will calculate a force of 6 Newton. Here we are having a force of 6 Newton of the same block. Same kind of block is there, and that block moves a distance of 2 meter. This block move a distance of 2 meter. We have to calculate the work done. So work done formula, firstly we will write W is equals to Fs. F is given 6 multiply S is given 2. 6 2s are 12. So work done is 12 joule. So in which case work done is more? In first case 10.5 joule is there, and in second case 12 joule is there. So in a B case work done is more as compared to A case. Clear? Like this you have to solve the numericals related to work.